Okay. So, looking at your book, I realize all of a sudden that, well, duh. If you subtract the projection of W onto this, which is orthogonal to this, from this, you get the projection of this onto this. So you don't need to project it onto the null space of the transpose, okay? I still like the picture, and I want to write out what's going on here, and then we'll simplify things a little bit. So, W equals this plus this, right?
Yes. Yeah. Yes.
So it's kind of important to understand that it implies that it equals that sum uniquely. And of course, it's obvious that if you add projection of W onto N to W minus the projection of W onto N, you get W, okay? And that, even better, you don't really need this projection. You got one projection, you got the other. And there's no reason you can't project it, but it comes out a little more elegantly, the way the book writes it. And it uses the fact that this thing's in the null space of A transpose. Okay? Now I'm still tempted to go on with the way I've notated it, just so you can compare it. That might confuse you, but we got a week for you to get out of the confusion.
Yeah.
And once you get out of it, you understand it even better because you understand it from two slightly different angles. Okay? This vector here is just what you get when you do A transpose times this, right? So this is A transpose applied to this, right?
I thought A transpose brought us up there.
No, A takes
Okay.
it this way.
Okay.
A transpose takes you the other way. Okay? And since this vector is unique, because you have this unique direct, unique breakdown into the direct sum, there's only one answer to this, which again is the parameters of your best fit model, whatever dimension, as long as n is less than that. But what's A transpose minus a vector in the null space of the transpose?
A transpose.
It's A transpose times W. Because this is in the null space of the transpose, it maps to 0, right? Okay? Now that's too simple, I don't like that. Something's wrong with that reasoning.
How does that actually, like, okay,
So
so.
that makes it too easy. You just multiply A transpose times this and you get this. I can't.
Right. Yeah.
So I'm missing something. So let's see what I'm missing.